How to overclock your Intel CPU on ASUS motherboard. For this video, I'm going to be using a 14900KS and the Z790 Apex, but this applies to any Z790 and Z690 ASUS motherboards and any LGA 1700 CPUs, K CPUs. It has to be a K. So for the first step, you're going to have to update your BIOS. I've already made videos on how to update BIOS, even different like I made an MSI gigabyte BIOS update guide a while ago. Update your BIOS. Second, you need to make sure that your RAM is stable before you overclock your CPU. And basically, you want to run Carhu for like 75K coverage, and you want to run TM51 OSMIS for 25 cycles. And that basically is good enough to, your RAM is going to be stable enough to overclock your CPU, so you won't have any issues because of the RAM. Now we're going to go into the BIOS settings, and I'll give you the CPU BIOS settings. Now that we are in the BIOS, you want to click F7, so you go to advanced mode. Then you want to go to the advanced tab, CPU configuration. Leave the so the first setting you want to mess with is virtualization. If you play Facet on CS2, or if you play Valorant, or if you play Fortnite comp, the anti-cheat needs this, so you leave it enabled. But if you don't play any of that, you can just disable it. I play that, so I'm going to keep it enabled. And then I like disabling my E-cores. So this is how you do it: active E-cores, efficient cores to 0. In my testing in gaming, it's better to have it disabled. And then hyperthreading, keep it enabled. And then CPU power management control, you want to set this to turbo performance, disable speed step, disable speed shift, turbo enabled, disable C states. And then now we go to extreme tweaker, and then just copy my settings here. ASUS advanced OC profile, manual, disable, remove all limits. Oh, you want to remove all limits. You want to do this, and then for your RAM, you want to make sure it's gear 2, which is 1 to 2 here. And then my RAM, I have my RAM stable at 8000, so keep it at 8000. Sync all cores, and then just leave this auto for now. We're gonna, when we're overclocking, we're gonna change this. Leave it auto for now. Then here, you don't have to touch anything here. AVX enable. User specify 0 for each. DRAM timings. This is specific to your RAM kit and your frequency and your RAM voltages. And then here, wanna change load line calibration to level 6. And then set this to 140, 100, auto. Switching frequency, set it to 500. Set this to extreme and extreme. That's it. Voltage caps, you don't need to touch this. Power management, you don't have to touch the thermal stuff. And then max this out. You want to max all of these settings out. Disable cap and disable SA cap. We're not going to touch AC and DC because we're going to do manual voltages, so you don't have to touch it. Thermal velocity boot, disable everything here. VF point, don't need to touch that. Tweaker's paradise. Don't need to touch anything here. Don't need to touch anything there. And then ring down bin disable. Set your cache / ring to 45. That's just the default. We'll overclock it at the end. And then disable this. Now you want to set your manual VRM to manual mode, and then set your vCore your core voltage override to 1.26, and then don't copy these voltages because these are specific to my RAM overclock, but I'll show you anyway if you want to see. And I'll just show you my RAM settings, but don't copy this. This is all just specific to my config I'm running for this video. Alright, now we're gonna go back into Windows and we're gonna start overclocking the cores. So I actually made one mistake. You want to make sure speed shift technology is enabled. Earlier in the video I had it disabled. You want to make sure this is enabled. Now we go into Windows. Now that we are back in Windows, you want to make sure you need the software called Benchmate. Just Google it and download it. We're gonna need Cinebench R15 Extreme, and we're gonna need hardware info. Now, depending on what CPU you have, your auto P cores is gonna be at different frequency. So my auto P cores on the 14900 KS is gonna be 5.9. Now, also remember that we set load line calibration to 6, and we set the V core to 1.26 volts, and that we have the cores auto, and the cores auto for this CPU is 5.9. So basically what we want to do is run Cinebench, and if it runs, then we're going to move on to OCCT, which is going to be the stability stress test. But at the voltages we're using, the voltages, the 1.26 is too low for this, so it's probably going to crash. So, and if it does crash for you, yeah, it doesn't even run. So now I'm going to lower the P cores. Lower the P cores 100 megahertz at a time. So now I'm going to go into the BIOS and lower the P cores to 5.8. So we're in the BIOS and we're going to set the P cores to 5.8. Right here, 5.8. And we're going to run Cinebench. So now we're back in Windows, and I have the P cores at 5.8. This also probably isn't going to run. 5.8 gigahertz usually needs more voltage than this, but let's see if I run a little bit. Yep, it's not going to run. So now, didn't run. I'm going to set the P cores to 5.7, and that should run, I think. We'll find out. So now the P cores are at 5.7. They should run. Let's see. Now there's two things you want to pay attention. It's to your core temperatures and how much power you're pulling. You want to make sure you're under 90 Celsius and that you're under 320 watts. And we are at 70 Celsius and at 190 watts, and it's running. Let's see if it completes it. And our core voltage is at 1.2. And that's like how I designed it. Load line 6 is I think it's like a 55-ish millivolt V droop, and we had 1.26. So look here, 1.25. So it drops 50-ish millivolts V droop, and it ran. So now what we do now. So now what you want to do is run OCCT, CPU plus RAM, and these are just the default settings. The default settings are fine. And you want to run this for, I like doing 5 cycles. You can do like 3. 3 is the lowest. At least do 3. But you want to make sure, like, if you do 3, you want to make sure it says 4, because that means 3 fully completed. And if you do 5, like how I like to do, you want the cycles to say 6. So if you look here, it's on cycle 1. And now while OCCT is running, you want to make sure that your core temperature is good. It's under 90 Celsius, and that your power, your watts are under 320 watts. Or if you can keep it under 250, that's like the Intel default. We have no power limits. We have the power limits all disabled. I like it like that personally. And it crashed. Okay, so we're gonna need more V-core. So now, if Cinebench runs but OCCT either fails or crashes or blue screens like that, basically you just need more voltage. So there's two things you can do. You can change your load line calibration so the voltage doesn't drop so much. So level 8 is a flat load line, so it would just stay at 1.26. I'm going to change it to load line 7. And so that's one way, by increasing the load, or in this case decreasing it, changing it from load line 6 to 7, 6, 7, the voltage is going to increase. Or you could increase the voltage here to like 1.27, something like that. Those are like the two things you want to do. So now we're gonna run OCCT again to see if it passes. So this is a nice thing about OCCT. It tells you when you crash. So we crashed at 32 seconds last time. So we're gonna rerun the test, and hopefully it's stable. So before it crashed, I was talking about the three things you want to look for. The three things you want to look for is your temperature. You want to make sure your CPU temperature, is under 90 degrees when stress testing. And when it comes to power draw, so in the BIOS we set unlimited power, which is fine because we're using low voltages right now. And power draw is interesting. If you don't want your CPU to draw a lot of power, then you just undervolt and you just downclock your CPU. Personally, I'm not worried about how much power my CPU is drawing. I'm more worried about the temperature and the voltage. And for the voltage, I like to keep I use under 1.35 volts load. So right now it's under load, and if I want to keep my CPU under 1.35 volts on the V core and my CPU under 90 degrees Celsius. Those are the two things I follow. Power draw, I'm not really too worried about in terms of drawing a lot of power. When you have the E-cores off, it's hard to pull like over 300 watts. So yeah, and look, we're at a minute right now. And so, and remember in the BIOS we changed the load line to mode 7, and we increased the V-core to 1.27, which you can see right here, and now it's drooping to 1.24. So I'm just going to let this run, and then if it's stable, I'm going to let it run 5 cycles. If it's stable, then we're going to go overclock the ring, or we might try to do 5.8 on the P-cores. We'll see if this is even stable. So we're back now, and I just took a screenshot of the OCCT run. It passed 5 cycles. You can see here it says 6, so that means it fully completed 5 cycles at 5.7 gigahertz. So now if your temperature is at 90 Celsius, then you can't push the CPU any further. But our temperature was like at 70 Celsius, so I'm gonna try to get 5.8 gigahertz. See if I can get that stable. So now I set the P cores to 5.8, and I set my V core to 1.3. So let's see if it runs Cinebench. Same load line 7. And it's running. We're at 77 Celsius, 200 watts, 1.27 V core. Like I said earlier, I like keeping my CPU under 90 degrees Celsius and my V core under 1.35. And it looks like it's gonna complete. And it ran. So now I'm gonna run OCCT to make sure it's fully stable. So it just errored 12 minutes into OCCT, and we were at, the temperature was at 88 at the high, 89 at the hottest. If you look here, the cores. So I'm gonna just increase the voltage just a little bit, probably from 1.3 to 1.32, and then that should be stable. So at 5.8 gigahertz, it passed. Passed 5 cycles. The temperature for a few cores, it went over 90, 91, 92. That's fine, as long as it's not, honestly, as long as it's not like 95 plus is what I'm worried about. But 91, 92 is fine on a few cores. The max power it drew was 270 watts. So it's fully stable at 5.8. If I had better cooling, I could push 5.9, because I'm only at 1.23 under no load and 1.28 under load for the V-core. So now we're gonna overclock the ring. So for overclocking the ring, basically all you do is you just see what's stable. Now if you're on 12th gen, you're gonna be probably capped around 48. You probably won't be able to go over 48 if you're on 12th gen. So if you're on like 12th gen, start at 48. If you're on 13th or 14th gen, start with 50. But for the sake of this video, I'm gonna try to rush this, but you would go one step at a time. So like 48, 49, 50, 51. The max on 14th gen you can do is like 5.2. But that's pretty rare. That's rare if a CPU can do 5.2 ring. This one I don't think will, so I'm just gonna do 5.1, and then you just run OCCT the same way, and if it's stable, then you're good. If 5.1 doesn't work here, if it errors in OCCT, then I would just have to lower it to 5 gigahertz. So now let's test it out. So it passed 5 cycles, 5.1 ring. The temperatures of the cores are highest. The hottest core was 93. And the power draw right now is 230 at 1.28 volts. So this is stable. And then we're done. We're literally done. We overclocked the peak cores and the ring. It's stable. And I guess I'll try 5.2. It's probably not going to work. It's rare that 5.2 works on one of these CPUs, but we'll try. So also I want to mention, don't forget to save your profile. Where is it? ASUS user profile, save your profile. You save it to 3, and then I'll just 8058 over 51. Boom. And so you just want to always save your profile once you're fully stable. And then we'll try 5.2 on the ring. Probably not gonna work, but we'll see. So I'm actually surprised. 5.2 on the ring lasted 45 minutes. It's frozen right now, so it just needs a little more voltage. So I need to just up it like 10 millivolts, and it'll be stable. But I'm not gonna do that right now. I have to edit this video, and I'm going on vacation, so I don't have time to make another run. But yeah, but that's basically it. That's how you overclock the cores and the ring. And yeah, thank you for watching.